हेलो माय डियर मैकेनिकल एंड सिविल इंजीनियर्स, व्हाट्सअप, कैसे हैं सब लोग? अपने कीमेनाचेन येलवनारू तुआड़ा कियाली. Myself Chandrasekhar welcoming you all to this wonderful session on the fluid mechanics, that is the Bernoulli's equation. So please do let me know if I am audible and visible to everyone so that we can start this beautiful session. Is my audio and video are fine? Hi Swapnil, Sumit, welcome, good evening. Please just write in the comment section if my audio and visual quality are good or not. Great Swapnil. Welcome Anubhav. So you guys are watching me live with the series which is the GATE and ESE 2024, which is running parallelly on YouTube, as well as not parallelly, which first part of the session will be on YouTube and the next part of the session will be on app, where we will have the quiz for the Bernoulli equation. All right. So this is my quick introduction for those who are attending the session for the very first time. I am mechanical engineering graduate from IIT Delhi, having more than 10 years of teaching experience in the field of GATE, IES and PSUs. I have also cleared engineering services examination conducted by UPSC. I had worked in Steel Authority of India Limited for a couple of years, and I have also worked in a private consulting firm for more than 2 years. I am quite comfortable in these many areas of mechanical engineering mostly, but the fluid mechanics is the common subject between mechanical and civil. Can you just write me how many of you are mechanical and who is from civil branch? Those who are from the mechanical engineering, please write M in the comment section, and those who are civil, please do write C in the comment section. Abhinav Negi sir from civil engineering is also there to support the civil engineering team for the war which is going to happen on the BYJU'S app. The quiz will be going to happen. It is not the physical war, but it will be the quiz, and the winner will get the exciting prizes as well. All right. Okay. So many students are from civil. So you can always connect with me through the mail ID which is there on the top of the screen. And if you are not part of my Telegram group yet, please do join me on the Telegram. That is Mechanical by Chandrasekhar. And the link is also mentioned at the bottom. Once you join me on the Telegram, then we will help you out in every possible way by providing the PDF and notes, the quizzes also, the practice questions, and the doubt clarification will also going to happen, because a lot of students are already there who are preparing for GATE or any other competitive examination, and those who are part of this Telegram group. So like-minded people, when they join a particular group, then by sharing the knowledge, you develop more confidence, you improve your preparation. So that is how the Telegram group is going to help you guys. All right. And along with the current series which we are here for, there is another series which is running on our YouTube platform, the previous 5-year GATE PYQs, both for civil as well as mechanical. If you have not joined any of the sessions yet, you can watch the recording, and the upcoming sessions you can watch the live, and you should subscribe our BYJU'S YouTube channel. This is the complete schedule. Let me hide myself. This is the schedule for civil engineering branch. This is the schedule for civil. We are at 15th June now. So the upcoming sessions, you can take a note of them. And for the mechanical also, today mechanics will be taken by Suraj Gopi sir, and from tomorrow onwards production technology will be going to start. All right. So this is the series which is planned on the students' demand, because we have been doing the civil versus mechanical war previously also, and students liked this concept a lot. With the students revise their concept along with the fun, and this time we have gone one step ahead by declaring the surprise gift hampers for all the top 5 students in all the 4 sessions. There are actually 4 sessions planned for strength of materials and fluid mechanics. You must already be aware, but please let me repeat it for those who are new joining. So yesterday Abhinav Negi sir had already taken a session on SFD and BMD. Today I will be discussing from 5 to 5:30. I will be discussing the theoretical part of Bernoulli equation, and from 5:30 to 6 p.m. on the BYJU'S app there will be a quiz both for civil and mechanical. Why we are having the quiz on our app, BYJU'S app platform, not on YouTube? The reason is very simple, because there is no opinion poll feature on YouTube. So the opinion poll feature is very beautiful, which is there on our app platform. That is why the quiz can best happen on the app only. So those who have not downloaded the BYJU'S app yet, please do download it, because the prizes will be distributed only after your score in the quiz, which is going to happen from 5:30 to 6 p.m. All right. And tomorrow again Abhinav Negi sir will be coming at 5 p.m. 5 to 5:30 for the theoretical discussion of thermal stresses, and then 5:30 to 6 the quiz for the same topic. You do not have to worry about what will be the quiz questions, from which topic the quiz questions will be asked. In the first half an hour we will make you comfortable with the concept, and in the next half an hour you are supposed to apply those concepts in numerical problems. That is the agenda, because in the examination it is all about application of the concept, right? And day after tomorrow again Joshit sir will be taking the fluid mechanics topic continuity, and the result for the winners will be declared on 18th of June, right? So let me quickly brief the rules, then we will directly jump to our theoretical discussion. All right, if anybody is having any doubt, anything to ask, you can always comment me through the comment section. The rule number 1 is, I have already told you, from 5 p.m. to 5:30 the class will be on YouTube for the concept discussion, and from 5:30 p.m. to 6 p.m. there will be a quiz on BYJU'S app for the same concept, right? Then every day the 3 top students' name will be noted. For today's quiz, Abhinav Negi sir have already taken the top 3 students, but let me tell you, if 2 students are getting the same mark, the student will be getting the top priority or the top rank in our leaderboard, who will give the answer with minimum time. So your click, your fraction of seconds to click the option is again very, very important. So top 3 students will be noted down, and 4 into 3 we will have 12 students name. We will have 12 students, and out of those 12 students we will select the top 5 students to distribute the gift hampers, and the announcement of those 5 students will be on 18th of June, right? So out of these 12 students we will select the top 5 students, and every day we will declare the mechanical team has won or the civil team has won based on these 3 students. If 2 are from mechanical and 1 is from civil, then the mechanical branch will be the winner on that particular day. All right. Acha, Vinod, better luck today. Ho jata hai technical. There might be a technical issue. We do not have much in hand for that. So I can only say you should be able to get the top 3 rank, 1 rank out of top 3 rank in today's quiz. What kind of questions you expect, the difficulty level, and the awards will be announced on 18th of June. Shall we start? Please make some noise. Those who are all ready. Those who are ready to explore this beauty, please do write Y in the comment section. Shall we start? Please keep your pen and notebook, and calculator will be required during the quiz. You are allowed to use the calculator. So keep your pen and notebook and try to mention the important concept what I am going to discuss. So you must have wondered how the aeroplanes generate the lift, how fast the liquid drain out from the container. So these concepts or these phenomena are easily explained by the most important and incredibly wonderful the Bernoulli equation or the Bernoulli principle, which help us to understand the fluid flow, all the aspects of the fluid flow. So the Bernoulli equation actually relates the velocity of the fluid, the pressure of the fluid, and the elevation of the fluid, and the equation was given or the published by Swiss mathematician and physicist Daniel Bernoulli. So the Bernoulli equation is about the energy conservation equation. So it is the part of fluid dynamics, right? The Bernoulli equation is the part of fluid dynamics, and the fluid dynamics is actually the analysis of the flowing fluid considering the forces which are causing the motions. So let me start with the beginning. What are the various forces which are acting on the flowing fluid? The majority of forces or the major forces acting on the flowing fluid are, one of them is the pressure force, which always acts normal and compressive, pressure into area. The other major force acting on the flowing fluid is the gravity force or the weight, m into g, which always acts in downward direction. And the third major force acting on the flowing fluid is the viscous force. Also, we can call it as the tangential force, or we can call it as the friction force in the fluid, frictional force, or we can call it as shear force. So the third force is shear, which acts parallel to the surface of the fluid, which acts the parallel to the fluid layers. And the another force which is acting on the real fluids, we are talking about the real flow. The next force is turbulence force due to mixing, which comes into picture due to mixing of the fluid particles with one another during the flow. So now, if we do not consider the turbulence force in our analysis, then we talk about the laminar flow. When all the forces are taken into consideration, then the flow is turbulent, because turbulence force appear only when the flow is turbulent. Then the top three forces are taken into consideration, then it is laminar flow. When we consider only the pressure force and gravity force in the analysis, the flow is said to be ideal flow, right? And the equation which is obtained by applying the Newton's second law or the momentum equation in the flow direction is known as Euler equation. So first of all, to understand the Bernoulli equation, we should have a little bit understanding about the Euler equation. And for understanding the Euler equation, we need to take these assumptions. The flow is non-viscous, or we can call it as inviscid, or we can call it as frictionless. What is the meaning of frictionless flow? Tau is equal to 0. There should not be any relative motion between the adjacent fluid particles. And the another assumption is the flow must be steady. So along the flow direction, if we take an element and apply the pressure force and gravity force, consider the pressure force, which is acting normal to the flow and compressive. Another pressure force is on the backward direction to the fluid element, and along with that, if we apply the gravity force, then by analyzing these forces and writing the Newton's second law along the flow direction, along the streamline, along the tangential direction, then we will get the Euler equation. We do not have time to derive it, but you can trust me on that. The derivation of this fluid element with the pressure and gravity forces, we are getting this expression. So the Euler equation is actually for compressible flow. It is developed for the compressible flow. This is the differential form of Euler equation. If we integrate this Euler equation, then we get integration of del P by rho plus V square by 2 plus G into Z is equal to constant. This is the integration form of Bernoulli Euler equation. And if we assume one more assumption, if we take one more assumption, if we assume the flow to be incompressible, then we obtained our well-known, very important, the beautiful Bernoulli equation. All right. So the assumption is taken as incompressible flow. What is incompressible? When the density remains constant during the flow. So if the density remains constant, then rho can be taken outside the integration, and integration of dP will be equal to P. So the equation will become P by rho plus V square by 2 plus GZ is equal to constant. This is the Bernoulli equation. I hope everyone know about it. Can you guys just let me know what is the unit of each and every term here? What is the unit of each and every term here? First term represents the pressure energy of the fluid. The first term represents the pressure energy of the fluid. The second term represents the kinetic energy of the fluid. And the third term represents the potential energy of the fluid. And the sum of these three energy is known as the total hydraulic energy. I am asking you the unit. That is where students commit mistake. Arun, arre nahi re. Hydraulic or mechanical energy of the fluid. No, it is not meter. मुझे बहुत उम्मीद थी स्टूडेंट से कि बहुत लोग मीटर इसको बोलेंगे. Mechanical energy of the fluid. Why do we call it as mechanical energy? Why the pressure energy, kinetic energy, or potential energy is called as mechanical energy? Because they can be easily, comfortably converted into mechanical work. So the total mechanical energy of the fluid always remain constant. Actually, the pressure energy is P into volume, pressure into volume, that becomes joule. The kinetic energy is equal to half into m into v square, that becomes joule. The potential energy is equal to m into g into z, that is joule, Newton meter. So if you see m, g, z, what is missing here? M is missing. Half m v square, what is missing here? M is missing. P into V, if we divide by mass, then it becomes volume upon mass is 1 by density. So each and every term represents energy per unit mass. The unit will be joule per kg. The unit of each and every term is joule per kg. Well done, Regan. Energy per unit mass. Dhruvil, joule per kg. Well done. Arun, Nitesh. Good, good. Please do not forget to like and share this session, guys, because there is going to be a mechanical versus civil war very soon. After 10 minutes, after 10 to 12 minutes, there will be going to be mechanical versus civil war. All right. So what we have understood is when the flow is steady, when the flow is incompressible, when the flow is non-viscous. So if these are the assumptions, so we can call these three parameters in a single term. When the flow is steady, incompressible and non-viscous, we can call it as ideal flow. We can call it as ideal flow. So we can say for an ideal flow, the total hydraulic or the total mechanical energy of the fluid always remains constant. So the Bernoulli equation is nothing but energy conservation equation for an ideal flow. What is an ideal flow? Ideal flow is the one which does not have any energy losses during the flow. Though ideal flow does not exist in reality, there is no flow which is ideal in reality. But to make our analysis simple, we ignore the losses and we can apply the Bernoulli equation. Are you getting it? I hope you are quite comfortable with that. Now quickly, if we multiply the whole equation by rho, then we will get another form of Bernoulli equation. If we multiply whole equation with rho, then we will get another form of Bernoulli equation. P by rho plus V square by 2 plus GZ is equal to constant. If we multiply whole equation by rho, because rho is constant, so the right hand side will become another constant. So the expression will be P plus rho V square by 2 plus rho G Z, either we write it as Z or H, it does not matter, is equal to constant. Now what is the unit of each and every term in terms of energy? What is the unit of each and every term here? Can you let me know? The unit of each and every term is Pascal, but I want your answer in terms of energy. Pressure into volume is pressure energy joule. So volume is missing. So each and every term represents energy per unit volume. Do you get it? Each and every term represents energy per unit volume. Energy per unit volume. Or we can call it as joule per meter cube, or we can call it as Newton per meter square or Pascal. So the first term is the static pressure of the fluid. P is the static pressure of the fluid. Can you just let me know P? Will it be absolute static pressure or the gauge pressure? P, will it be absolute or gauge? The second term represents the dynamic pressure of the fluid. What is the dynamic pressure? The pressure developed due to kinetic energy of the fluid. The pressure developed due to kinetic energy of the fluid. That is called as dynamic pressure of the fluid, rho V square by 2. The third term represents the hydrostatic pressure, that is due to gravity. Due to gravity. Is it absolute or P can either be absolute or gauge? It does not matter. You can take it as gauge pressure, you can take it as absolute pressure. That is purely your choice. All right. So if we join this P plus rho V square by 2, static pressure plus dynamic pressure becomes the piezometric pressure. This becomes piezometric pressure. And the sum of static pressure and hydrostatic pressure, the sum of static pressure and hydrostatic pressure will become, the sum of static pressure and hydrostatic pressure, P plus rho Gz will become, P plus rho Gz will become the piezometric pressure, and static plus dynamic will become the stagnation pressure. This will be the piezometric pressure. Right? P plus rho Gz will be the piezometric pressure, and P plus rho V square by 2 becomes the stagnation pressure. Static pressure plus dynamic pressure is the stagnation pressure of the fluid, and static pressure plus hydrostatic pressure becomes the piezometric pressure of the fluid. If we divide by rho G, if we divide the equation, complete equation by rho G, then we will get another form of Bernoulli equation. That is the third form which we frequently use in our questions or numericals. So first term will become P by rho G, that is the static pressure head of the fluid. The second term V square by 2G, that is the velocity head, or we can call it as kinetic energy head, or we can call it as dynamic pressure head. Dynamic pressure head. The third term is the static head, or we can call it as, the third term we can call it as potential energy head, or we can call it as datum head, or we can call it as elevation head. So the total energy head, what is the unit of each and every term in terms of energy now? What is the unit of each and every term in terms of energy? This is called as total energy head. Sum of static pressure head, potential energy head and kinetic energy head will be constant. That is called as total energy head of the fluid. And Z is nothing but a vertical distance from a reference line. You can take any horizontal line. You can take any horizontal line, and the vertical distance, it can be positive, it can be negative. The vertical distance from a reference line will be the value of Z. So each and every term, M into G is in the denominator, mgz by mg. That becomes Z. You can see the last term. So mgz is energy, joule, upon mg, it is the weight. So the unit is joule per Newton, and joule is Newton into meter. So Newton into meter upon Newton will become the meter. So this is the third form of Bernoulli equation. So if I summarize, please try to understand. If I summarize, there are three ways in which the Bernoulli equation can be written. First form, we can say that is energy per unit mass. Second form, that is in terms of pressure, that is energy per unit volume. The third term, that is in terms of head, that is in terms of head of flowing fluid. All the parameters are in terms of head of flowing fluid. We can call it as energy per unit weight. So what are the various assumptions to apply these Bernoulli equation? Let us quickly understand those assumptions, and then we will discuss a couple of examples. First assumption is the flow must be non-viscous, inviscid, or frictionless. The second one is the flow must be steady. Pressure, density, velocity are not a function of time at all. The third term is incompressible flow. Density is neither be a function of space nor time. Density remains constant. And the fourth one is no heat and mass transfer. It means there is no energy transfer from the fluid to outside or from outside to the fluid. No any other form of energy transfer outside the fluid. And the last but not the least, the fluid flow is, or the Bernoulli equation or the energy conservation is applied along the streamline or along the tangential direction or along the flow direction. The equation is applied along the flow direction. These are the various assumptions. A quick update: there is a workshop going to be conducted by Rakesh Talreja sir on 20th of June at 7:30 p.m. Do register yourself for this beautiful workshop. He is going to discuss how to clear the GATE examination in 8 months. And the link to register yourself is already there in the description box. All right. Yes. So if we apply the Bernoulli equation, how it is applied? Quickly, let us try to understand how the Bernoulli equation is applied. If there is a flow, if there is a fluid flow from 1 to 2, the flow is from 1 to 2. This is point 1, this is point 2. The flow is taking place in from 1 to 2. So we take a reference line. Then we take a reference line. Let us take this horizontal line as the reference line. The vertical distance of point 1 is Z1. The vertical distance of point 2 is Z2 from the same reference line. Any horizontal line can be treated as a reference line, and the flow is ideal. It means there is no energy loss. Ideal flow means if we ignore the energy loss, then we can say total hydraulic energy or the total mechanical energy of the fluid at 1 is equal to total hydraulic energy of the fluid at 2. So in terms of, if we write in terms of head of flowing fluid, P1 is the static pressure at 1, Z1 is the potential energy head or the height of point 1 from the reference line, and V1 is the velocity of the fluid. So in terms of flowing fluid head, we can have this as our Bernoulli equation, but there should not be any energy loss. But the energy conservation is actually universal. The energy conservation is universal. But if we want to apply the energy conservation for the real flow, considering the losses, there are energy losses in real flow, considering losses, then what will be the nature of the energy equation? We will not call it as Bernoulli equation now. This is again point 1, this is again point 2. The flow is taking place from 1 to 2. The flow is taking place from 1 to 2. So we can say energy at 1 is equal to energy at 2 plus the energy loss from 1 to 2. And in terms of head, if we want to write, this is Z1, vertical height from the reference line of point 1, and Z2. So the total energy at 1 will be greater than the total energy at 2. So the energy equation in terms of head will take this form in terms of head. There is one more term coming to picture. This is the total energy head at 1. This will be the total energy head at 2. And this HL is known as energy head loss, or we can call it as frictional head loss. Frictional head loss. We can call it as frictional head loss in the flow direction. HL from 1 to 2. Right? Getting it? But if the flow is from 2 to 1, if the flow is from 2 to 1, then what we will say? We will say energy at 2 is greater than energy at 1. If the flow is from 2 to 1, then energy at 2 will be greater than energy at 1. the losses always take place in the flow direction. The losses always take place in the flow direction. So our energy equation will look like this: P2 by rho g plus Z2 plus V2 square by 2g is equal to P1 by rho g plus Z1 plus V1 square by 2g, plus loss term will be added in the term 1, or we could have written in terms of pressure also. So the conclusion here is the fluid always flow in the direction of decreasing total energy of the fluid. In the direction of the flow, the total hydraulic energy always decreases, or we can say in flow direction, and the total energy of the fluid always decrease. If the direction of the flow is known, we can write the energy equation with the losses. Losses term will be added in the direction of decreasing in the direction of the flow. All right. So that is all about this. There is an scholarship test. So please guys, be ready to join me on the app where we will be having the quiz for the next 30 minutes. So share this session or share this information to all your friends. There will be a scholarship test on 18th of June. The link is already there on the description box. So let me quickly move to the. So there are some other series which are running. So this is the entire schedule of our mechanical versus civil war. And this is my session which is going to be conducted on app at 7 p.m. All right. So the event is now live on app. So do join me on the app with your calculator, with your pen and notebook. And the quiz will happen on the app because there is an opinion poll feature on the app. All right. So see you guys there on the app. The link to join the app is already there in the comment section. The link is already there in the comment section. All right. Thank you, Anubhav. Thank you, Arun. Thank you for your participation. Now, all the very best. Now, it is your time to perform. The questions will be simple but conceptual. So, let us meet on the other side of the session, that is on our app. So, let me signing off from here. I am not signing off. The screen will be visible here, but do join me on the app. Thank you, guys. See you on the app.